Hey guys, hello, I'm back. We are going to study API management in this video. Previously, we learned more about the security solutions, let's say, the key vault, managed identities, and configuration. I am a bit lagging because I couldn't get my sleep very well. Today we are going to step into another topic. It's not a security solution this time. It's for the API management, and there is one specific or dedicated resource in Azure for this purpose. In this manner, I will read it. This is going to be a quite slow conversation, I think. Maybe it doesn't, but I will just start. We will see how is it going to be. First of all, what is API? API is we use to serve some information or some data implement. We serve data by the API. Through the API, actually, the API can be served on various ports or on various protocols. Probably you all know about the HTTP based APIs or HTTP. Related ones, but API basically means the set of functions you can call from a different device, right? API, the abbreviation means the application. What it means, man? Application interface, but application. What is P then? API. REST API, RESTful API, RESTless API is a set of rules. Yes, stands for Application Programming Interface. Exactly. Let's jump into the topic. API management provides the core functionality to ensure successful API program through developer engagement, business insights, analytics, Security and protection. Each API consists of one or more operations, and each API can be added to one or more products. To use an API, developers subscribe to a product that contains that API, and then they can call the API operations such as to any usage policies. API management components. The API management is made up of an API gateway, a management plane, and a developer portal. These components are Azure hosted and fully managed by default. API management is available in various tiers, different in capacity and features. API gateway is the endpoint that accepts the API calls and routes them to appropriate backends. Variety verifies API keys and other credentials presented with the requests. Enforces usage quotas and write limits. Transforms requests and responses specified in policy statements. I think this API management thing is very important. If you like to get some certificates, and they will definitely ask, because I was there. I know they are asking. The enforces usage quotas and write limits, transforms requests and responses specified in policy statements, caches responses to improve response latency and minimize the load on backend services. Caches the responses to improve response latency and minimize the load on backend services. Responses to improve response latency and minimize the load on backend services. Emit logs, metrics, traces for monitoring, reporting, troubleshooting. Management plane. That was the gateway part, huh? The gateway. The first component. Gateway handles the requests, apply quotas or limits, verifies credentials, route them to the correct backends, transform requests, headers, maybe body as well, caching, logging, metrics, tracing. The management plane is the administrative interface where you set up your API program. Use it to provision and configure API management service settings. Let's read again. The management plane is the administrative interface where you set up your API program. Use it to provision and configure API management service settings. Define or import API schema. Define or import API schema. Package APIs into products. Define or import API schema. What is an API schema, man? API schema is a structured definition that describes how an API works, including its endpoints, request response formats, parameters, authentication, and error handling. It acts like blueprint or contract for developers to understand how to interact with an API reliably and consistently. Common API schema formats. OpenAPI, Swagger, REST APIs, YAML JSON. Okay, yeah, I think now I understand what it means after seeing this one. GraphQL, STL, VSTL. Yeah, VSTL for sure. Very good. Package APIs into products. Package APIs into products. Set up policies like quotas or transformations on the APIs. Get insights from analytics. Manage users. Developer portal is an automatically. Let's recap the management plane. What is the purpose of it? Provisioning and configuring API management servers settings. There are some settings. Provision and configure API management. Okay, define or import the API schema. Okay, API schema. Some service settings. Package APIs into products. Set up policies like quotas, transformation. I'm first using, but this is setting part. Okay, this is the management part. This is imagine this as the traffic policeman. This is the department, the police department, or maybe the law setting the rules, right? This guy here makes sure that all the traffic goes as intended. And the management plane, and then developer manage users, get insights from analytics, and blah blah. Developer portal is an automatically generated, fully customizable website with the documentation of your APIs. Using the developer portal, developers can read API documentations based on the schema, probably call an API via the interactive console. Okay. Create an account, subscribe to get API key, access analytics on their own usage, download API definitions, manage API keys. I've just read the products. something. And now groups, administrators, developers, guests. Developers represent the user accounts in an API management service instance. Developers can be created or invited to join by the administrator, or they can sign up from developer portal. Each developer is a member of one or more groups, can subscribe to the products that grant visibility to those groups. Policies are a collection of statements that are executed sequentially on the request or response of an API. Popular statements include format conversion from XML to JSON. Policies are a collection of statements that are executed sequentially. Policies are a collection of statements that are executed sequentially on the request or responses of an API. Popular statements include format conversion from XML to JSON and call rate limiting the restricted number of incoming calls from a developer, and many other policies are available. Policies expressions can be used as attribute values or text values in any of the API management policies. Policy expressions can be used as attribute values. Policy expressions can be used as attribute values or text values in any of the API management policies. Policy expressions can be used as attribute values or text values in any of the API management policies, unless the policy specifies otherwise. Some policies, such as control flow and set value variable policies, are based on policy expressions. Policies can be applied at different scopes depending on your needs: global, product, specific API, or an API operation. Your solution might contain several front and back-end services. In this scenario, how does a client know what endpoints to call? What happens when new services are introduced? How does the client know what endpoints to call? What happens when new services are introduced or existing services are refactored? How do services handle SSL, termination, authentication, and other concerns? The API management gateway, also called data plane or runtime. Exactly. Runtime is the service component that's responsible for proxying API requests, applying policies, and collecting telemetry. An API gateway sits between clients and services. It acts as a reverse proxy. routing requests from clients to services. It might also perform various cross-cutting tasks such as authentication, SSL termination, and rate limiting. If you don't deploy a gateway, clients must send requests directly to backend services. However, there are some potential problems with exposing services directly to clients. It can result in complex client code. The client must keep track of multiple endpoints and handle failures in a resilient way. It creates coupling between the client and the backend. The client needs to know how the individual services are decomposed. That makes it harder to maintain the client and also harder to refactor services. A single operation might require calls to multiple services. I'm thinking the gateway as Nginx or something. They are working as reverse proxy or reverse proxy. I'm not sure of these terms. Proxy versus reverse proxy. Acts on behalf of client. Used by users to access external resources. Clients accessing internal services. Clients accessing internal servers. Typical use case: hide client, access control, content filtering. Reverse proxy, load balancing, caching, SSL termination. Proxy website. Client is hidden from the internet. Reverse proxy, internet, reverse proxy, internal IP server. Server is hidden from the client. I got it. Server is hidden from the client. Yeah, think about the tunnels. There is only one server does the proxy and the client uses the internet through that server. So that server knows the clients, but the whole internet doesn't know the client. They only know that gateway, the proxy server. But on the other hand, if you put that proxy in front of the server side, then it will be named as a reverse proxy. Then the servers are hidden. Previously, the clients were hidden. Okay. I got it. Where were we? It acts as a reverse proxy, routing requests from client to services. It might also perform various cross-cutting tasks such as authentication, SSL termination, rate limiting. You don't deploy a gateway, client must send requests directly to backend services. However, there are some potential problems with exposing. Yeah. Each public-facing service must handle concerns such as authentication and SSL and client rate limiting. Okay. Yeah, that's true. Actually, that's maybe that's the biggest problem. Each individual service then should concern about authentication, SSL, rate limiting. But if there's only one gateway, if they all pass through that, then there is only way you do this handle the trouble, and then pass the clean request to other services. Very good thinking. Services must expose a client-friendly protocol such as HTTP or WebSocket. This limits the choice of communication protocols. It limits the choice of communication protocols. Services with public endpoints are a potential attack surface and must be hardened. API management offers. Yeah, let's continue with it. Managed and self-hosted. API management offers both managed and self-hosted gateways. Managed by Azure, self-hosted by yourself. Probably by Azure enthusiasts. Managed gateway is the default gateway component that is deployed in Azure for every API management instance in every service tier. With the managed gateway, all API traffic flows through Azure regardless. Sorry, my microphone was off. I take it from the start. I take it from start. I will take it from the start. Let's start from the beginning. Managed and self-hosted. API management offers both managed and self-hosted gateways. Managed by Azure, self-hosted by developers. Managed gateway is the default gateway component that's deployed in Azure for every API management instance in every source tier. With that managed gateway, all API traffic flows through Azure regardless of where backend implementing the APIs are hosted. Yeah, it basically says you can host, look, with the managed identity, all the API traffic flows through Azure, regardless of where backend implementing the APIs are hosted. Can be some servers on demand, or what was the name of it? Some servers not hosted in Azure, maybe hosted in even Hetzner, or I don't know, Amazon, or on your home, in your home, self-hosted. A gateway is an optional containerized version of the default managed gateway. It's useful for hybrid and multi-cloud scenarios where there's a requirement to run the gateway of Azure in the same environments where API backends are hosted. The self-hosted gateway enables customers with hybrid IT infrastructure to manage APIs hosted on premises. That's the keyword. That's the word, on premises and across clouds from a single API management service in Azure. Let's explain. Let's make OpenAI to explain the self-hosted requirements, benefit, samples. Sure. A self-hosted gateway is a containerized version of an Azure API management gateway that you can run outside of Azure, on-premise, on Edge, or in another cloud, AWS. It extends Azure API Management to any environment, letting you manage and secure APIs closer to where they are actually running. Benefit: manage APIs running on premises, in private networks, or in other clouds. Reduced latency. API traffic stays local instead of routing through Azure. Centralized management. Still use Azure Portal to manage all the API. That's the thing. You're not delivering the whole API management concept. You just put the gateway on premises server. Yeah, Azure does that for other type of purposes too. For example, for network peering, right? Keeping the on-premise and the Azure communication private, not unexposed to public internet or internet. Yeah, so that's the thing. And that API gateway, this is different than app gateway. Okay, Centralized management. Still use Azure Portal API ARM to manage all APIs, even those running off Azure. Works offline. Continues functioning even if temporarily disconnected from Azure. Standard DevOps friendly deployment. Deployment steps. Azure Gateway Resource. Azure API Management Gateway Create. This is creating in Azure. Generate access token. Showcases token API Gateway show access token. Very good. To run the container with that token. Deployment steps. High level. If the self-hosted gateway runs outside Azure, why do I still need to create a gateway in Azure? Short answer, because Azure still manages the configuration, monitoring, and security of the self-hosted gateway. Even though it's physically running elsewhere, you still need to create that resource then. But show access token, can you run it somewhere? Interesting. Create APIs in Azure API Management. Create a gateway resource. Run the Docker container for gateway using Azure issued token. Gateway connects securely to Azure, syncs configuration. Now local clients can use the gateway to call APIs without traffic ever hitting Azure directly. Let me know if you like a full explanation. I got it, man. Looks very useful, huh? Okay. Explore API policies. In Azure API Management, policies allow the publisher to change the behavior of the API through configuration. Policies are a collection of statements that are executed sequentially on the request or response of an API. Policies are applied inside the gateway that sits between the API consumer and the managed API. The gateway receives all requests and usually forwards them unaltered to the underlying API. However, a policy can apply changes to both the inbound request and outbound response. Policy expressions can be used as attribute values or text values in any of the API management policies. Unless the policy specifies otherwise. Understanding policy configuration. The policy definition is a simple XML document that describes a sequence of inbound and outbound statements. The XML can be edited directly in the definition window. Yes, inbound, backend and outbound, and on error. The configuration is divided into inbound, backend, outbound and on error. The series of specified policy statements is executed in order for request and response. Inbound statements to be applied to the request. Backend statements to be applied before the request is forwarded to backend servers. Forwarded to backend servers. Then after inbound, is that statements to be applied before the request is forwarded to the backend servers. Okay, inbound, backend, and then request is handled by the code. Response is generated. Then response comes to again to the gateway, and then outbound policies. Outbound policy statement to be applied to the response. If there is an error, condition statements to be applied if there is an error condition. If there is an error during the processing of a request, any remaining steps in the inbound, backend, outbound sections are skipped. Processing skipped and execution jumps to those statements in the error section. By replacing policy statements in the error section, you can Review the error by using the context lost error property. Inspect and customize the error response using setBody policy and configure what happens if an error occurs. Let's read from start again. Not from start, but from the second sentence. By placing policy statements in the on error section, you can review the error by using the context.lostError property. Inspect and customize the error response using the setBody policy and configure what happens if an error occurs. Okay, we will see the examples. Policy expressions. Unless the policy specifies otherwise, policy expressions can be used as attribute values or text values. In any of the API management policies, a policy expression, unless the policy specifies otherwise, policy expressions can be used as attribute values or text values in any of the API management policies. I read this third time. I don't know what does it mean. Definitely confusing at first. Here's a clearer explanation. Original statement. What it means. In Azure API Management, you write policies. Correct. To control how requests and responses are handled. Very good. For example, to modify headers, set timeouts, or check tokens. Policy expressions are bits of C# style codes that let you add logic inside these policies. The statement means you can use expressions inside policies either in attributes or in the body, unless a specific policy says you cannot. Okay, you can use a policy expression like this inside an inbound policy. Set header policy name X user ID exists action override. If there's already had a X user ID, then it will override it, right? The value context user identity dot name. You get the user name from the context under user property and then identity, the name is a policy expression. Okay, this is an expression statement. This is a statement. Or policy. This is an expression. And it's being used as a text value inside value. Exactly. You can also use it inside an attribute like this. This is the attribute. And you can use it inside an attribute too. For example, region, say. Original statement. Unless the policy specifies otherwise, I think we will come to this. Probably we will come to this. Policy expressions can be used. Policy expressions that long sentence, right? Dot dot dot. The expression can be used as attributes, like this one. Or text values, like this one, value, in any of the API management policies, unless the policy specifies otherwise. Unless, yeah, exactly, we will, I told you we will come this. Some policies don't allow expressions in certain places. Those will be clearly documented. Otherwise, it is safe to assume you can use expressions. Give me an example to this. Course policy example. The course policy in Azure API Management doesn't allow policy expressions inside its configuration. This is a real case of policy specifies otherwise. Expressions are not allowed. Invalid example. Allowed origins. Origin, you cannot get the origin from somewhere. You need to type it. Course. Allowed origins. And the sub elements, the children elements, can be different from expression to expression. Course set value, set header, right? Set header, set variable. In contrast, set header allows expressions. So we know. A policy expression is either a single C# statement enclosed in print as whatever you call, or multi-statement C# code block enclosed in this that returns a value. This is interesting. Here, var response, then C#, for loop, even for loop. Looks like a function to me without taking parameters. Apply policies specified at different scopes. We are here. Each expression has access to implicitly provided context variable. Implicitly provided. Okay, not explicitly. Implicitly provided context variable and allowed a subset of .NET framework types. and an allowed subset of .NET framework types. Some subsets. Policy expressions provide a sophisticated means to control traffic and modify API behavior without requiring you to write specialized code. Modify backend services. The following example uses policy expression and set header policy to add user data to the incoming request. The added header includes the user ID here associated with the subscription key in the request. Subscription key. The added header includes the user ID associated with the subscription key in the request and the region. Okay, inside this one. The region where the gateway processing the request is hosted. X request context data. Setting one header with two values in it. I'm not sure how is it going to look like. Comma separated, space separated. Let's ask ChatGPT then. How is the output of the policy look like? There are small issues with your example. It has two value elements inside a single header, which is not a valid syntax. According to Azure API policy rules, policy can have only one, but this is a Azure documentation, right? You tell that, but Azure tells different. Okay. You are wrong. See this. Confirms that you can include multiple value elements in a single header policy. My earlier response was incorrect. Very good. Your original policy works, assuming the resulting will be comma separated. I think it's just assuming. Apply policies specified at different scopes. If you have a policy at the global level, and the policy configured for an API, then whenever that particular API is used, both policies are applied. API management allows for deterministic ordering of combined policy statements via the base elements. policies inbound cross-domain based find and replace. Let's read the text again. If you have a policy at the global level and the policy configured for API, there are two policies, right? Then whenever that particular API is used, what policies are applied? API management allows for deterministic ordering of combined policy statements via the base elements. If you have a policy at the global level and policy configured for an API. In the previous example, policy definition, the cross-domain statement will execute first. The find and replace policy will execute after any policies at a broader scope. I got it. There is no predefined ordering, but you use the base element and you can define what will be the order. Okay. Find and replace policy will execute after any policies at a broader scope. Then you can think that the more granular or specific location policies are being executed first. Not they are executed first, but it's given chance to execute them first. They decide. Filter response content. The policy defined in the following example demonstrates how to filter data elements. The policy defined in the following example here demonstrates how to filter data elements from the response payloads based on the product associated with the request. Snippet assumes that response content is formatted as JSON and contains root level properties named minutely, hourly, daily, and flagged. Policies: inbound base, backend base, outbound base. After everything runs, choose. This is one statement, policy statement. Right? Choose. When and then set body condition and response status 200, product name equals starter, product name starter and 200. Note that we are not using preserve content true when deserializing response body stream into a JSON object, since we don't intend to access it again. Set body response. We get a response. Right, we get the response. And then we have a for each here for those elements. Minutely, hourly, daily, flags, and response.property. And we give the key here. Remove minutely, hourly, daily, flags. These properties are getting removed. Then response getting converted into string. First it was string, probably, but then it's a JSON object or something. Okay, we need this to be summarized and noted. Yes, next one. I got some nuts. Sorry if it bothers you, but I want to eat, okay? Anyway, nobody watch the video. Next unit, advanced policies. This unit provides a reference for the following API management policies. Control flow. Conditionally applies policy statements based on the advanced policies. Control flow. Forward request. Limit concurrency. Lock the event hub. Mock. Retry. Conditionally applies policy that determine results of the evaluation of Boolean expression. We see them one by one. Very good. Control flow. Choose when and then set body. It was. The control flow policy must contain at least one when element. The otherwise element is optional. Yeah, like if else. conditions in when elements are evaluated in order of their apparent within the policy. Policy statement enclosed within the first when elements are applied. Policy statements enclosed within the first when elements are applied when the condition attribution is true. Policies enclosed within the otherwise element is very good. Forward request. You see that? Condition, right? Then condition, and then set body. This is the statement. Not shown here. Forward request. Policy. Forward the incoming request to the backend service specified in the request context. Forward request policy forwards the incoming request to backend service specified in the request context. The backend service URL is specified in the API settings and can be changed using the set backend service policy. Removing this policy results in the request not being forwarded to backend service. The policies in the outbound section are evaluated immediately upon the successful completion of the policies in the inbound section. Request is not being forwarded. Look. You might omit when mocking responses. No need to construct backend. Send the request entirely in the inbound outbound policies. Okay, you put this, then you call set in the outbound stuff. You set the body for mocking. I got it. Mocking policies. function for making requests. Forward request. Nu mitä? Concurrency. Nimän concurrency on pois ja prevent unclosed policies. You guys fail immediately with too many requests. Very good. Useful. Log to event hubs. Log the event hubs policy sends messages in the specified format to an event hub defined by a logger entity. As its name implies, the policy is used for saving selected request or response context information for online or offline analysis. Partition ID. Partition key. Let's start some examples. Backend. Forward request. Very good. This is the message, right? You can directly give the message here. Example policy. What is this then, man? Syntax? Yeah. Incoming request to blah 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 blah. Logging. What it does, logs a message like useful for tracking and telemetry. Start calling external IPs inside your policy. Requisite, set up the logger. First you need to set up the logger. Event hub. Event. Connection string. Let's see the examples. Policy allows you to return a predefined response without calling the backend. This is a mock to response. Policy inbound. You want it inside the inbound, right? Yeah. Why would I need mock response if I have set body in backend? Great questions. Quick and simple way to return mock response without backend call. build custom response manually, usually after or instead of backend call. Set body can be used inbound, backend, outbound, on error. Okay, another way, just another way. Because you can also do that with the set body, I understood. If I use set body backend section, does it prevent the call, or how to prevent calling the service? Not prevent the request from being sent to the backend service. How to prevent return response? Inside the backend, if you say return response, status, header, set body. Very good one. Look, return response. That's the one. That's the beauty. Retry policy executes its child policies once and then tries their execution until retry condition becomes false. Condition count interval max interval delta first retry. Okay, let's see examples. Policies inbound and then backend. And forward request. That is 500. Try multiple times, yeah. Okay. Give me brief explanation of each and a sample policy for each. Control flow, choose. Very good example, huh? Choose when, set header, choose. Under the choose when, you have another when. If the method is get, if the method is post, if the otherwise forward request. forward the request. What happens if I forget to put forward request? Immediately returns, right? Will not be sent to the backend service. Mandatory. Limit concurrency to 5. Unlock the event hubs. Mock response. Retry. Return response. Let's continue with the unit 6, secure APIs by using subscriptions. Exactly. You need to subscribe, man, otherwise you cannot use it. When you publish APIs to API Management, it's easy and common to secure access to those APIs by using subscription keys. Developers who need to consume the published APIs must include a valid subscription key in HTTP requests when they make the calls to those APIs. Right? The API Management Gateway rejects calls without the subscription key, and the calls are not forwarded to the backend services. To get a subscription key for accessing APIs, a subscription is required. A subscription is essentially a named container for a pair of subscription keys. Developers who need to consume the published APIs can get subscriptions. To get a subscription key for accessing APIs, a subscription is required. A subscription is essentially a named container for a pair of subscription keys. Yes, to get a subscription key for accessing APIs, to get a subscription key, a subscription is required. A subscription is essential a named container for a pair of subscription keys. Developers who need to consume the published APIs can get subscriptions, and they don't need approval from API publishers. They don't need approval from API publishers. The API publishers can also create subscriptions directly for API consumers. Can also create subscriptions directly for API consumers. API publishers can also create subscriptions directly. Yeah. As a developer, either you can subscribe or the API publisher can do it for you. A subscription key is a unique auto-generated key that can be passed through in the headers of the client request or as a query string parameter. The key is directly related to a subscription, which can be scoped to different areas. Subscriptions gives you granular control over permissions and policies. 3 main subscription scopes: all API, single API, product. A product is a collection of one or more APIs that configured in API management. You can assign APIs to more than one product. Products can be different access rules. Use quasi term. Applications that call a protected API must include the key in every request. You can regenerate these subscription keys at any time. For example, if you suspect that a key has been shared with unauthorized users, you can generate. Every subscription has 2 keys, primary and secondary. Having 2 keys makes it easier when you do need to regenerate the key. For example, if you want to change the primary key and avoid downtime, use the secondary key in your apps. For products where subscriptions are enabled, clients must supply a key when making calls to API in product. Developers can obtain a key by submitting a subscription request. If you approve the request, you must send them the subscription key securely, for example, in an encrypted message. This step is a core part of the API management workflow. For products where subscriptions are enabled, clients must supply a key when making a call to the API in that product. Developers can obtain a key by submitting a subscription request. If you approve the request, you must send them the subscription key securely, for example, in an encrypted message. This step is a core part of the API management workflow. Call an API with the subscription key. Applications must include a valid key in all HTTP requests when they make call to API endpoints that are protected. This is important. Protected by a subscription. Keys can be passed in request header or as a query string in the URL. Keys can be passed in the request header or as a query string. Okay. Default header name is OCP APIM subscription key, and the default query string is subscription key. To test out your API calls, you can use developer portal or or command line tools such as curl. There is an example of a GET request using the developer portal. To test out your API calls, you can use the developer portal and command line tools such as curl. There's an example of a GET request using the developer portal. It shows subscription and key header. Even in the developer portal, I need to pass the subscription key. Huh? Here is how you can pass a key in the request header using curl -- header, curl -- header. There's an example curl command that passes a key in the URL as a query string. Pass subscription key and then this. Next. Secure APIs by using certificates. Certificates can be used to provide TLS mutual authentication between the client and the API gateway. You can configure the API Management gateway to allow only requests with certificates containing a specific thumbprint. The authorization at the gateway level is handled through inbound policies. API Management Gateway is configured to require client certificates on inbound requests. The client must send a valid certificate trusted by API Management. Okay, this is this is for APIs, for the public stuff. Between client and API, not the API gateway and the services. Okay, I'm confused that. I thought it's the communication between the API gateway and the services. But this is the communication between client and the API. Okay. With TLS, API Management Gateway can inspect the certificate contained within the client request and check for properties like certificate authority. Only allow certificates signed by blah blah. Thumbprint, right? Allow certificates containing a specified thumbprint. What is thumbprint? Unique identifier for digital certificate. What exactly is a certificate thumbprint? It's a hash value computed from the certificate's data Think of it like a digital fingerprint, unique to each certificate. It's fixed length. When you allow certificates containing a specific thumbprint, you are telling the system only trust this exact certificate. No other certificate, even if issued by same authority, will be accepted. This makes your API more secure by tightly controlling which client certificates are valid. Subject expiration date. Client certificates are signed to ensure that they are not tampered with. Client certificates are signed to ensure that they aren't tampered with. They are not tampered with. Explain. What is a signed certificate? Client certificate is a small digital file. Yeah, signed, not the signed certificate, man. Tempered. Focus on the tempered means someone has altered or changed something without permissions, especially in a way that's meant to deceive or cause harm. Ensure they are not tampered with. When a partner sends you a certificate, verify that it comes from them and not an imposter. There are two common ways to verify a certificate. Check who issued the certificate. If the issuer was a certificate authority that you trust, you can use the certificate. You can configure the trusted certificate authorities in the Azure portal to automate this process. Ensure you trust the source of any self-signed certificates. Accepting client certificates in the consumption tier. Yeah, okay, let's see the tiers. There were some tiers. Feature-based comparison of the Azure API Management tiers. Whoa, whoa, whoa. Look at that. Consumption tier, developer, basic, basic V2, standard, standard V2, premium, premium V2. There are a lot. Microsoft Entra integration. Developer, yes. Basic, no. Consumption, no. Virtual network injection support. Developer, yes. Premium, yes. Outbound virtual network integration. I cannot remember everything. A consumption tier in there is a free. Okay, let's see if there is a free tier. Now, consumption developer, basic, standard, premium. Basic, standard, premium. Consumer developer, basic, basic 2. Standard, standard 2, premium, premium 2, maybe standard is 1. I don't care too much, okay? Consumption tier in API management is designed to conform with serverless design principles. If you build your APIs from serverless technologies such as Azure Functions, this tier is a good fit. In the consumption tier, you must explicitly enable the use of client certificates, which you can do on the custom domains page. This step isn't necessary in other tiers. Explicitly enable certificate authorization policies. Create these policies in the inbound processing policy file within the API Management Gateway. Create these policies in the inbound processing policy file within the API Management Gateway. Okay, you click APIs, then Weather Data API, Revision 1, Design, Content, Inbound Processing, then Policies. Too much click, man. Design, Settings, Content. Create authorization policies. Create these policies in the inbound processing policy file within the API Management Gateway. Check the thumbnail of a certificate. Every client certificate includes a thumbprint, which is a hash calculated from other certificate properties. The thumbprint ensures that the values in the certificate haven't been altered since the certificate was issued by the certificate authority. You can check the thumbprint in your policy. The following example checks the thumbprint of the certificate passed in the requests. Condition: request.certificate null, request.certificate thumbprint, desired thumbprint. Return condition: set status, return response. if not equal. Okay. Check the thumbprint against certificates uploaded to API management. In the previous example, only one thumbprint would work, so only one certificate would be validated. Usually, each customer or partner company would pass a different certificate with a different thumbprint. To support this scenario, obtain the certificates from your partners and use the client certificates page in the Azure portal to upload them to the API management resource. Then add this code to your policy. Check the thumbprint against certificates uploaded to API management. If there is a certificate, if there is not a certificate, or certificate verify is null, is false, or context deployment certificates, any of them has that thumbprint. Okay. Check the issuer and the subject of a client certificate. Issuer and the subject of a client certificate. This example checks the issuer and the subject of the certificate passed in the request. This example checks the issuer and the subject of the certificate passed in the request. Condition: if there is no certificate, or the certificate issuer blah blah, or subject name blah blah. Okay, very good. Very nice. Group creation, API management creation, API management creation. Let's copy that. Location, publisher email. What is the publisher email for? Publisher. Okay. Subscribers will get an email from the publisher. That publisher. Should have an email to send emails, right? Email address. Resource group, publisher name, consumption. Import a Backend API. This section shows how to import and publish an Open API specification Backend API in Azure portal. Search for and select API Management Services. From the API Management Services screen, select the API Management instance you created. In the API Management Service navigation pane, select APIs and then select APIs. Select Open API in the Create from Definition section. and set the basic full toggle to full in the pop-up that appears. Select Open API in the Create from Definitions section. Select Open API in the Creation from Definitions section and set the basic full toggle to full. And then you give the specification path, display, name, description, URL. You register it here. Then boom, API settings. Big conference API is created. Now it's time to configure API settings. In the web service URL field, the select subscription required checkbox. Test the API. Very weak example. Exercise. Very weak. Check your knowledge. Which of the following components of the API management service would a developer use if they need to create an account and subscribe to get an API key? Which of the following components of the gateway portal developer API management service will a developer to use if they need to create an account and subscribe? Developer portal. Which of the following API management policies applies a policy based on a condition? Blah 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 blah. Yes, we did it. Thanks.